Hey everybody, Mr. Bucko here with a couple of examples from section 7.6 on function notation. We're going to go over a couple of functions and evaluating them at given variables. So on the screen here we have an example of a function. We have f of x equals 2x minus 1, and this is read f of x, not f times x. This is what function notation is. It's a way to write functions or equations in a format that we have not seen before that we are now talking about. So we have f of x. F is not a variable. F stands for function. The name of this function is f, which is why the f is here. So we have f of x equals 2x minus 1. And with this function we can do a lot of things. We can plug in various values of x and evaluate the function at those values. So what we're going to do here is evaluate f of 5. And I'm just picking 5. I could have picked anything that I wanted to pick, and I'm picking 5, and we're going to evaluate f of 5. So we are going to evaluate this function when x is 5. So what I'm going to do here is, instead of plugging in x, I'm going to plug in 5, because 5 has replaced x in the function. So if I do that, it will look like this. We have f of 5 is equal to 2 times 5 minus 1. So we've replaced the x with a 5, we've replaced the x with a 5, because we are asked to evaluate f of 5. So we have f of 5 equals 2 times 5 minus 1. We can do 2 times 5, that is 10. So then f of 5 is equal to 10 minus 1, and as a result f of 5 equals 9. So if we evaluate f of 5, we find that f of 5 is equal to 9, and this is what we have for our answer. F of 5 is equal to 9. We don't solve for f. F is not a variable. It is the name of the function. And what's nice about function notation is that you can clearly see the input and its corresponding output. So when we input 5 into the function, we get out 9, which is kind of the handiness of function notation. You can see what you plug in and then what you get out as a result. Another example, if we're given a function with the equation f of x equals 5x minus 19, and we're going to find f of 2, which is just like evaluate f of 2. We're going to find f of 2 by just plugging in 2 for x. So we're going to have f of 2 is equal to 5 times 2 minus 19. 5 times 2 minus 19 is equivalent to 10 minus 19, which is equal to negative 9. So as a result of this, f of 2 is equal to negative 9. When we plug in 2 into this function, we get out negative 9. Another problem here, example, we're given a function, h of x now. I'm using h instead of f. The function can be called really whatever you want, h, f, g, e, L, you can name it whatever you want here, and that's just handy for when we name or use multiple functions. So we have h of x is equal to 2 times the quantity x plus 4, and we are going to find h of 3 plus h of 7. So what we're going to have to do here is evaluate the function twice at two different values for x, and then add those values, because that is what we are asked to do right here. So the first thing I'm going to do is find h of 3, because I need to find h of 3. h of 3 is equal to 2 times the quantity, 3 plus 4. Evaluating that, or doing the math, order of operations, adding what's inside the parentheses, we get 2 times 7. And then we get h of 3 is equal to 14. So when we plug in 3 into the function, we get out 14. Therefore, h of 3 is equal to 14, given this function. So I have h of 3, now I'm going to find h of 7. h of 7 is equal to 2 times the quantity, 7 plus 4. So when I plug in 7 into the function, this is what I get. Order of operations, adding the 7 and the 4 together, I get 11. 11 times 2. h of 7 equals 2 times 11, therefore h of 7 is equal to 22. We are asked to find h of 3 plus h of 7. Now that we know what h of 3 and h of 7 are, we can find that. h of 3 is 14, h of 7 is 22, and that equals 36. And once again, h of 3 is equal to 14, h of 7 is 22, and 14 plus 22 is 36. So therefore, h of 3 plus h of 7 is equal to 36. Last example, we have another function. This one's called g, so we have g of x equals 7x minus 3. For what value of x does g of x equal 32? So what we're doing here now is working backwards. We want 7x minus 3 to be equal to 32, and we want to find out what do we have to plug in for x such that this will be equal to 32. So this is what I have. G of x, which is 7x minus 3, needs to be equal to 32. Why should it be equal to 32? Because we are asked to make it equal to 32 and then find out what the value of x has to be. So I have to find out, well, when does 7x minus 3 equal 32? What does x have to be so that this is the case? And we can use basic algebra to find out what that is. If I have 7x minus 3 equals 32, what I'm going to do to both sides of this equation is add 3. If I add 3 to both sides of the equation, I get 7x equal to 35. By getting rid of the minus 3, by adding 3 to both sides, that's why this is a 35, because 32 plus that 3 is 35. And then divide by 7, and you get x is equal to 5. So for what value of x does g of x equal 32? 5. If we plug in 5, if we find g of 5, if we evaluate g of 5 will be equal to 7 times 5 minus 3, which is 32.